Good day. Welcome to the Davis Introduction to EnviroMonitor. I'm Brett Lane. I'm the Tech Support Director at Davis Instruments. And we also have Joel O'Cam, Account Manager in our Sales Department as a panelist on here.
Good morning, everybody. Glad you could make it.
So what we're going to do today is going to be a broad overview of our EnviroMonitor system. We've got some slides, should take about half hour or so. We'll have some room at the end for some questions, but you can actually answer or ask questions throughout the presentation in the Q&A section. If you look at the bottom of your screen, in a little menu, you should see something that says Q&A. That would be a great spot to ask questions as we go, to type them in there, and Joel will be monitoring that and answering them as quick as he can if there's a lot. And then at the end, if we have some time left, which we likely will, we can go over some more questions. Okay, so get the Q&A window up, and we can get started. All right. So once again, welcome to an overview of the Davis EnviroMonitor system. We're going through some slides here. Feel free to answer questions, and hopefully you can find this valuable. Just a quick overview of Davis Instruments. We were established in 1963 by two owners, privately held. Initially, it was a marine product, is what we initially had. A lot of gadgets for motorboaters and sailboaters and things like that. And then we purchased a meteorological sensor manufacturer, and then off we went into the weather world. We've been manufacturing weather stations for decades and decades. We've got a whole line of weather stations suitable for anybody's kind of needs. What we're talking about today is our EnviroMonitor system. That actually is targeted a little bit more towards agriculture, but it can really be used anywhere. You'll see by the end of this that there's lots of applications for it. But primarily, we're pushing into the ag industry with this system. I mentioned weather stations. We have weather stations all over the world. This is a map showing you kind of the numbers in particular regions. The color is showing you the temperature of that particular area, the aggregate temperature of all the stations in there. So you can see that we've got over 50,000 weather stations worldwide, reporting into our cloud, into our weatherlink.com site. So the EnviroMonitor system, a very specific, unique type of weather station from Davis. What it allows you to do more than our other weather stations, right? The standard weather station is typically a sensor or two that you put outside. Maybe it's mounted on a sensor suite. We call a sensor suite a kind of conglomeration of sensors that you can mount on a pole in one shot. Typically that transmits back to a console or something somebody indoors looks at to see what the conditions are and the values are from those sensors. That can also be pushed up to the web and viewed online. But with the EnviroMonitor system, what we can kind of branch out and move into and expand with the EnviroMonitor system is remote locations. We have a system that has a cellular modem in it that will transmit the data back to Davis. That's what you can see here, the gateway and EnviroMonitor gateway. Here's an example of a sensor suite: rain collector, temperature, humidity, and wind on top of the pole here with the gateway. And then what we have out here are what we call nodes. So these are sensor transmitter stations that you can spread out into the field. We'll talk about distances and how far they can go. And that all brings the data back through a mesh network, which we'll talk about what that is. And then the data goes out the cellular network to the cloud, and then you have various applications to view the data, right? So there's our website, weatherlink.com, where you can view the data. Mobilize app, you can view the data. And we have a couple more apps that can let you view data and set up the system, which we'll go over as well. Okay, so that's just kind of a rough idea of what the system does there. So the components, we kind of already talked about what the components are. So this is the EnviroMonitor gateway, large solar panel on it. That will charge a battery inside, power the cell phone modem as well as the receiver to digest all the data from the nodes. So here's an example of a node. Now, once again, it's got a solar panel. It's got a couple different batteries inside to run the system, and the sensors will plug into there, up to 4 sensors per node. Then we've got a whole slew of sensors, not only Davis sensors, but a whole slew of third-party sensors. It's up in the hundreds now. I'm not quite sure if we got into 200 yet, but we support many third-party sensors. So looking a little bit closer at the gateway, like I said, this is the motherboard, the home base, the device that listens to all the sensor data and then transmits it out over the cellular network back to the Davis cloud so that you can get at the data and view the data there. So it's got a 5-watt solar panel on the front there. We've got a 6-volt, 12 amp hour battery inside that the solar panel charges up. That battery by itself with no sun or no solar panel would last about a month. So you get some good time out of the battery if you've got some dark winters or some cloudy times and charging isn't too optimal. We've got a lot of extra room in that battery to keep it running. It can receive up to 25 nodes. Not many people get quite that far. We'd love if you did, right? The more nodes, the better. But beyond 25 nodes, the mesh network gets a little busy. So too much transmission on the network kind of clutters the receiver up and makes it a little more difficult to hear. So we kind of recommend people keep it under 25 nodes. Beyond that, you could probably say 25 nodes and maybe 75 sensors. Sensors are, extra data too. That's a transmission. So the more sensors you have, the more transmissions that are going through the mesh network. So we want to kind of keep it to 25. The networks that are larger than that, we've got a number. They'll typically split it into 2 gateways. They'll split it in half or in thirds and put out multiple gateways to handle that many nodes. Weather-resistant housing, obviously, the fantastic part of this system, we've got a lot of wonderful feedback on this, is to set up the system, you just simply need a smartphone with Bluetooth. So you'll go out to the site, you'll get close to the gateway, you'll pull up the EnviroMonitor app. We'll talk about that a little bit later. And you connect to it with Bluetooth and you configure it. You give it a name, you tell it to turn on. You have a choice of different data rates. There's 3 different choices. You can have data sent to Davis either every 5 minutes, every 15 minutes, or every 60 minutes, okay? So you'll see your data records at that interval, as well as that's how quick it comes out of this gateway through the cell network to us. So with a couple of simple questions on the phone app, via Bluetooth, it sets it up, it turns it on, it activates the cell modem and the SIM card, and it's online. We have CDMA, GSM, as well as LTE versions of this gateway. So we've got a lot of options there for anybody domestically in the US or worldwide. We've got SIM cards that work in virtually every country. There's probably a couple that we can't support, but virtually every country in the world we can. So real easy setup with the smartphone. Of course, it comes with mounting hardware, some U-bolts. You can attach it to a pole or a post, different things like that. And one of the last bullet points there is the service plan. That's that 5, 15, or 60. Obviously, if you got a slower transmission rate, 60 minutes, that plan would be a little bit cheaper than the 5-minute plan, etc. We've got a question there. What if you have a bad cell service, right? So the next slide here is what we call the IP gateway. So it's a gateway in all respects. It hears all those nodes, up to the 25 nodes again, right? The mesh network outside, all kinds of sensors plugged in, being transmitted back. But this gateway is not cellular. This is a Wi-Fi or an Ethernet gateway. So if you have poor cell reception in your area, but you do have internet access, you've got a router or something that you can get on Wi-Fi or plug directly in with Ethernet, this would be the way to go. It'll still listen to all those nodes out there, and then send the data to the cloud through your router and your internet connection there. So looking through the bullet points here, Wi-Fi Ethernet, we covered that. Needs to be on AC power, right? These radio chips use a lot of juice. Our backup powers are just the 4 AA batteries. How those are used, if you lose, it's a nice feature here. If you lose a network connection, if you lose an internet connection, this gateway will buffer and hold all the data coming in from all the sensors. And when the internet connection comes back up, it sends all the data out, all the data that you missed, and so it catches up. So if you look online at your database online, you won't have any holes or gaps in your data. It'll fill all those in from the outage because it had been saving them and sending that on up. Okay. So once again, that can be Wi-Fi or Ethernet. If you don't have Wi-Fi, you can plug it right into a router, a hub, a switch, things like that to get it on the internet. But you will either need internet with this device or back with the prior product, cellular connection. Our experience is there are some places that don't have cellular, but it's relatively rare these days. But they are there. So in those cases, the IP gateway would be the way to go. The backup batteries in there, they last for around 7 to 10 days. Depends on how much it's listening to. So the way the backup batteries work is if we lose primary power, we will turn off the internet connection, which uses lots of power. We don't want to drain the batteries too fast. And the 4 AA batteries will keep the gateway alive so it can hear the sensors and do that buffering and hold on to that data. And then once the primary power comes back, we'll get back on the internet and shoot all that stuff up. So the batteries, they're about 7 to 10 days of backup, which we don't expect too many people to have the typical blackout of that long. So you should have plenty of power there. Another difference between the two is the cellular gateway. As it's designed now, can listen to a Davis sensor suite. I'll show you what one of those is in a second, but that's that big bundle of sensors that comes in one kind of mounting apparatus. We have two different transmission technologies for that sensor suite. One is a cabled version, RS-45, so we just run a cable into a device, or it's a wireless transmitter, and it transmits over the airwaves, and then a receiver on the other end hears it. This cellular gateway needs to have a cabled sensor suite. It needs to have a cabled sensor suite mounted above it and plugged right into the gateway. Whereas the IP gateway can listen to both our wireless sensor suite or our cabled sensor suite. There's a jack on the side. You could plug the cabled sensor suite in if you need to. Okay. The nodes, right? So the nodes, we've got another little bit smaller box. This is going to be out where you want to monitor things, and it's going to transmit the data back over what we call a mesh network. I'll describe that here in a bit. It can take up to 4 sensors. You see the 4 wires coming out of the bottom there. So in the vicinity of this device, you can have up to 4 sensors planted in the ground. If you need more, you get another node. What happens in a mesh network is, got a good diagram later that I'll show you. In fact, I can go back to that. Well, we'll see that later. We'll get to that in a little bit. When it transmits its information out, it transmits this on what we call this mesh network. So basically what that means is every single node out there acts as a retransmitter. So if any node out there can hear this particular node, it'll take that data and send it on to the next node that can hear it. And it intelligently makes its way back to the gateway so it can be sent to Davis, okay? There's a term we use called parent, which is the device that's upstream from the node. So the mesh network is always active, just at the microsecond level. It's talking to each other, it's chirping, it's finding out who's near it, who it can talk to, who's got a louder signal, and it chooses a parent to transmit that to. And then that parent picks its parent, and it goes all the way back and eventually makes it back to the gateway. The wonderful part about the mesh network is it's fault tolerant. So if you have, I'll go back to a slide here that we showed earlier. 1 second. Yeah. So here's kind of a simple example of a mesh network. You can see the red lines there that some of those nodes can't quite get all the way to the gateway. It's a little too far. So they're going to transmit to a nearby node, and that nearby node is going to pass it on. So what I meant by fault tolerant is if one node has a problem, right, gets run over by a tractor, stolen, falls over, something, power runs out, something grew up over the solar panel and it lost power. Um, then the nodes prior to that will find a different node to go to. So that's what I mean by fault tolerant. You lose one node, it figures out its own path back. And it's always trying to assess the optimum path. But if we lose that path, it'll just pick another path and make it back to the gateway. Okay. So when you install it, you need to make sure that those paths are reachable, right? If your node can only hear one other node, then it's really going to be dependent on that one other node to get back to the gateway. So having things in reach of each other is ideal, so you can get that fault tolerance and multiple transmission paths back. You can see here on the bullet point 2, communication range up to 10,000 feet. So there is a default antenna that comes with the system inside that box. With that, you're going to get probably 2,000. I've seen people up to 4,000 with just that default antenna. But we do provide external antennas that you can add to it. It doesn't come with the system, you purchase that extra. But there's a reverse SMA plug inside the node as well as inside the gateway. And you can attach one of our long-range external antennas onto it. We have two. We have an 8 dB antenna and a 5 dB antenna. So this spec here of the 10,000, that's with the 8 dB antenna. If you put an 8 dB antenna on both ends and you elevate them sufficiently high, I've got a diagram here soon that I'll show you, you can get 10,000 feet between the two. I know when I'm talking to people or my tech support folks are talking to people, we try to advise you not to go out to the limit. Everybody wants to push it and go as far as they can. Maybe it worked when you installed it, but it's a risky gamble. The signal might be somewhat weak, and with some changes in the environment, whether it's the crop growing up taller, the floor changing because the crop's growing up taller, or whether it's RF in the air or different environmental conditions, it can change things a bit. So if you really go too far, you're running a risk there. I keep the distances acceptable. If you want extra assurances and confidence, add an external long-range antenna and make sure that the data can get back. It's got a 3-watt panel on it. Same way, you configure it with a smartphone. So you use what we call our EnviroMonitor app. We've got a few apps. The EnviroMonitor app is what you use to configure this, just like with the gateway. You walk up to the device and you say that you want to add a node. You make a Bluetooth connection with it, and you name it, and you kind of define what network it's on, and then it's added to the system. So the kind of the flow process with the EnviroMonitor app is you go to the gateway first. That's the mothership, right? You add that, you define that, and then you start adding either a sensor suite to that gateway, or you start adding nodes to the system. Once you've added a node, then you move on and you start adding sensors. So with the same app, using Bluetooth on the node again. You pick which sensor you want to add, it adds it, it's all seamless, starts working and runs along. We've got 2 batteries inside this node. There's a rechargeable lithium battery, 3.7 volts lithium battery. That's getting charged by the panel. That's powering the system at all times. If we lose the sun, or like I said earlier, crop grows up over the panel, things like that, we can't charge that lithium battery. We'll use the 4D cells to keep the system charged up and running. Those 4D cells in the node, those last about 23 days. So our thought is with the kind of intermittent need to lean on the D cells, 23 days should be plenty to get you through the year. You definitely should not have to place the D cells within a year. In fact, I don't know if I've recalled anybody replacing the D cells because they just eventually drain. Normally what happens is you get enough sun on the panel all year, even in the winter, to get that lithium battery charged up. We can charge the lithium battery full in probably say an hour of good sunlight, maybe 2. And that full lithium battery, if the sun disappeared, then would have about 4 days of power. So between that rechargeable lithium battery and some level of sunshine, even in the winter, you're getting that lithium battery charged up, and you never really go and lean on the D cells, but they're there, and they can provide the backup power to get you over the hump. Okay. Somebody asked a question: the useful life of the battery in. I assume they mean in the cellular gateway, the big 12 amp hour cell in there. We think that's 5, 7, 10. We don't really know. I mean, at some point it will get tired of being charged and discharged, charged and discharged. Once again, I don't recall, at least from the tech support angle, of anybody calling with a battery that just eventually gave up the ghost and said, I'm tired of living. Usually what we'll see is there's been some issue and the solar panel gets covered either by the crop or, birds landing on it and defecating on it, things like that. Something that covers up the panel and prevents the charging. That's when we really, we see powering issues, right? We can't charge the battery and the battery eventually drains and the system turns off. But life of the battery, haven't seen one yet, but we think it's about 5 to 7 years. The moving on, the system components. This is a picture of a sensor suite. We have a number of different kinds of sensor suites. This one here is what we call a grow weather sensor suite. I'm going to use my mouse here. We've got a passive radiation shield down here with a temperature and humidity sensor in it. This is a rain collector. The shape of this mitigates wind. Wind hitting a cylindrical cone and bouncing off and up and over it and around it really affects the way the rain falls into it. So you can get lower readings than you should have. So this kind of mitigates the effects of wind. Nonetheless, still be aware of that and try not to get it in too uneven area. It comes with these spikes on top that prevents the birds from landing on it and defecating in the rain collector. Still need to clean that rain collector out. You'll get pine needles, dust, dirt, debris. You'll see stuff in there. So every 6 to 12 months you want to get out there and clean it off, depending on how dirty your environment is. But these spikes on here will keep the birds from sitting on the edge of it. I mentioned wind on the rain collector. That's why we give you this 40-foot cable on the anemometer, so you can mount the anemometer up extra high if you need to. You can keep this down low, out of the effects of the wind. Wherever you feel it's appropriate. Mounting guidelines differ between agriculture and meteorological and different things depending on what you're doing. But typically in agriculture, I believe, Joel, chime in here if you feel differently, but I think you go about 5-6 feet off of some turf, typically with a sensor suite.
Yes.
So go ahead, Joel.
Predominantly in agriculture, you want that to be where you need to get your measurements. So if the wind is up, if you have your anemometer up at 30 feet and your crops are at 10 and you're applying sprays at 10 feet, that anemometer is too high, for an example. And in reverse can be the same way. If your orchard's 20 feet at the top and you're doing aerial spraying, you don't want the anemometer down at 10 feet.
Yeah, good point. Good point. Positioning of the anemometer, especially if you're looking at wind for spraying reasons, put it where you need to monitor. Same thing with the temperature, humidity. Where do you need to get your information? Now, you'll notice something else on here. This device here on the left. This is a solar radiation sensor. So to calculate evapotranspiration, you will need a solar radiation sensor. So that's why this grow weather system has the solar radiation sensor on it. And that with pressure, temperature, humidity, wind, we can calculate an evapotranspiration value for you. We also, you can see there, we calculate other things, dew point, wind chill heat index off the temperature, humidity, and wind, things like that. So there's some wet bulb. So there's some calculated values that will also generate off of these sensors. All these sensors plug in to this transmitter here. This is a cabled transmitter, a wired transmitter, so there's no solar panel on it. The cable that comes out of it will plug directly into either one of those gateways and send the data down there, and power for the whole system will come up from that gateway over that wire, so no solar panel here. If you had a wireless version of our sensor suites, we would have an antenna on the side to transmit, and we'd have a 3-volt lithium battery inside with a small solar panel on the front. And that will run the wireless system. We have many different kinds of sensor suites. This one here has a passive radiation shield. We have some with a fan aspirated radiation shield that will have a fan inside of it that will be constantly spinning and pulling air in and bringing air through. So that's often advisable for people who have really low wind environments or no wind environments and a steep temperature gradient. So if the temperature is going from, like deserts often do, they'll go from 40 at night to 100 in the day within a few hours. The air inside there might be a little bit old. It might take a little while for the air to kind of wick in or blow in through the side, especially if you have no wind. If you've got just a mile or two of wind, it'll blow the current air in there, and you won't have that issue. But no wind, virtually no wind, and a lot of quick temperature changes, a fan aspirated model would be advisable. We also have models with a UV sensor on here, not typically needed for agriculture, hence the grow weather doesn't have it, but there's also a UV sensor we could put on there. So we have a variety of sensor suites that can meet your needs. Typically the grow weather is the one that we'll use out in agriculture. Sensors on the nodes. I mentioned that we could take all the Davis sensors, so temperature, humidity, rain, wind speed, direction, leaf wetness. We have a soil moisture probe, an Irrigation watermark soil moisture probe. All these Davis sensors can plug into this node. That's no problem. But really, the exciting part about this is it can take all kinds of third-party sensors. So we have a lot of soil moisture probes, either single point, they bury in the ground and gives you the soil moisture, sometimes temperature, sometimes salinity, an EC value with it. And we also have, we support profile, soil moisture profile probes, long probes with multiple sensors that go into the ground and give you soil moisture from different levels, like the Centex and the AquaChecks. Water level sensors for wells, lakes, ponds, things like that. Leaf wetness, a weighing sensor. I talked to somebody the other day in a greenhouse environment. They had this mounted underneath a bed of plants that they were growing, and they were monitoring the weight to assess how wet it was for irrigation purposes in the greenhouse. They wanted to see when it got to a certain weight it needed to be watered. Pressure sensors and switches for irrigation piping. The sensor is going to give you a PSI value. The pressure switch is just going to say if there's pressure or not, on off kind of a thing. Flow meter also can attach to irrigation pipes. We have large ones meant for very large irrigation pipes, but also small ones that can fit on the drip systems. And that's going to kind of monitor the flow rate and the gallons passing through there. Solar radiation, PAR sensor, another one we'll commonly see out in agriculture and in greenhouses and whatnot. Temperature, humidity, wind speed. Carbon dioxide was a new add. We're adding sensors all the time. We just recently added the small flow meter for the irrigation. We're about ready to add a Judd ultrasonic depth sensor that doesn't feel pressure and the depth of the water. It measures the distance, bounces radio waves off it. So we're constantly adding sensors, and the CO2 from Atlas Scientific was one that we just added, is not on here, to measure CO2 levels indoors or outdoors. These are some of the companies we support. I say some because, like I said, we're adding them all the time. I didn't update the slide. We've got some new companies as well, so you can see there all the different companies that we support. Most all of these companies have multiple sensors that we support. So when you're using that EnviroMonitor app and you're choosing what sensor to add, initially you'll pick the sensor type. We'll say soil moisture. Then it'll list the manufacturers that you see here of different soil moisture probes. Once you pick that, then you'll see a long list of part numbers and different types, different lengths, different sensors. Some are only soil moisture, some have temperature and salinity sensors as well. And you kind of pick individual part numbers and add that specific one. Okay. The nice part about adding the app using the app too, besides the convenient Bluetooth setup, is that it gives you the wiring diagram for all these sensors. All these sensors have different numbers of wires, different colors of wires. So we provide, use my cursor here, we provide this little green connector for the node that plugs into the node. Remember, the node has 4 ports. And when you go and add a particular sensor, it tells you exactly what colored wires go where. And if you're using a Davis sensor, the Davis sensors typically come with an RJ plug on them, like a phone plug. And what we have to accommodate that is a little adapter that turns that RJ into this this green adapter with these six pins on it, so it can plug right into the gateway. The convenience of that is you don't have to strip our plugs off, cut our plugs off, strip the wires, and try to thread the wires into the jack. There's just a little interface plug to plug right in. So for Davis sensors, you want to make sure you don't forget to purchase that. It doesn't come with the node. Not everybody needs it, but if you do, purchase it. I believe it's part number 6860. If you do forget that and you're in the field installing and you don't have that adapter and you're using a Davis sensor, you can, there'll be a little link similar to this one here, not quite exactly as this one, but a similar one here that you'll click on and say, I don't have that adapter from Davis. What do I do? And then it'll show you the wiring diagram, and you can cut our phone plug off and install it right in. So configure with Bluetooth using the app. This is an example of the EnviroMonitor app. Here's where we're going to make a Bluetooth connection. Here's the different sensor types, right? So I talked about that earlier. This is where you're going to pick the sensor type, the manufacturer, and then the specific part number. Then it's going to show you the wiring diagram. You plug that in, and then you're virtually done. The phone app configures the system, tells it what to expect, and you're off and running. It's that easy. It's really a slam dunk. Also within this EnviroMonitor app, there's some diagnostic information in kind of a menu in the upper right. It normally would be up here where this question mark is. Looks like a stack of 4 papers. When you click on that, you get a number of options, from looking at your battery voltage to your mesh network signal strengths and things like that. So you can kind of assess. That's really good if you're new to the system and you're trying to get some length out, or you're not sure how far things are, to look at that signal strength and see that it's getting a little bit weak. Maybe I need to put things closer. If you can't put things closer because you need a monitor in this spot, the nodes act as a repeater just by default. So if you're out too far and there's nobody in range, but you really need a node in that spot, just drop another node partway up the path there, and you don't even have to install sensors on it. You just add it as a node with the app like you would normally, and then just skip the sensor part, and it behaves as a repeater. It'll listen to anything that can get to it and transmit it on. Okay. So distances can vary, right? We talked about that earlier with these nodes. So node to node or node to gateway, you're typically going to get 2,000 to 4,000 depending on conditions. You can add extra antennas on there to get farther, but typically you're looking in the multiple thousands. There's a lot of variables that go into play. I'm going to jump ahead to a slide since we're kind of talking about that now. Let's see here. Yeah, skipping ahead a little bit. So this kind of illustrates distances, right? This is not, this table here is not meant to give you the exact max distance it can go in your situation. There's lots of variables at play. Distances can vary. This is meant to just give you an idea of the ranges you're getting. Does it go 10 feet? Does it go 50 miles? I don't know. What's the so this kind of gives you an idea of what to expect out of it. This diagram here is using just the default standard antennas. But what this kind of illustrates and helps when you go to install it is, if we're under canopy, there's lots of obstacles. There's lots of tree trunks, right? Wood filled with water. Right? Those are going to hamper the transmission range. So you would typically see 300 to 500 feet. 300 when you're going through a lot of trunks, 500 when you kind of have a straight shot down the row and can kind of see the other node, kind of a thing. Just because you can see the node doesn't mean it's a clear open site and you can get 2,000 feet or something. The trees on the side of it still block some of that signal. The radio signal's a big transmission, and things on the side, below it on the ground, all that stuff tends to hamper the signal a bit, even though you can see the destination, right? So that's why you get the 300 to 500 feet on here. These other pictures, they're illustrating two things for us that are important. One is you need to, height matters, right? And so the closer to the ground you are, or the crop top, that's why we have this corn in here, is it's not the distance above the ground, it's the distance above the crop, right? So that surface below it, whether it's crop or ground, will hamper that signal that's trying to transmit out horizontally. So the closer to the ground you are, the more interference you're going to have with the signal. So that's why we have the 6 feet versus 10 feet kind of idea here to show you that you can get farther the higher you elevate it. I mentioned power and crops growing over the solar panel earlier. Keep that in mind. I'll see people sometimes mount it in a way that it works now, but the crop grows up. And then they call us later with transmission problems. And we can clearly see, looking at some of these health metrics that I mentioned, that that signal strength was slowly degrading day by day, week by week, and it really looks like, the crop's growing up and maybe not even covering the system, but it's just getting closer to it. And now your virtual mounting height is only 1 foot, and you're not going to get a lot of distance there. So mounting height matters and crop matters, right? Think of the crop as your floor and think of the maximum height of the crop and get it an appropriate distance above that. This is just kind of showing you the idea of, this says 20, probably 25 plus now is probably a little better to say. But you can have your many nodes, they all wind up transmitting the gateway and then out to the cloud. But the real important part here is this diagram to kind of illustrate just general distances. Like I said earlier, with the high gain antennas, you can get 10,000 feet, almost 2 miles. That's with 8 dB antennas on both ends and elevated at 10 feet, right? So 8 dB antenna on both ends of the thing, elevated up 10 feet high, you'll probably get a couple miles. I say probably because everything's different. So test it as you go out there, or try not to push the max limit. This slide here, we'll go back to the apps in a second. This was kind of an orchard installation that we did a while back. This has 18 nodes in it. And this serves to illustrate really well mesh networks and how they work. So they're always looking for the optimal path back to the gateway. You can see here, the gateway is mounted in this corner. Each one of these dots is a node, right? So these are all nodes out there with sensors attached to them. And the arrows are showing you the path it's taking to get back to the gateway. The green arrow indicates it's a common direction it goes, a common parent that it's using. The yellow means it occasionally will go to that to make its way back to the system. So this mesh network is just dynamically on the fly down at the sub-second level determining who it can hear and what the best optimal path is. So it's likely gonna switch around on you daily, depending on how you set it up, right? If it doesn't have a whole lot of options, it might just go one way, or if one option is really strong, it might always stay on that option. Like I think this E3 here would always go this way and never move. But some of these out here, farther away, occasionally it'll feel like the signal isn't as optimal as another, and it'll switch, right? It'll switch to another one. So you can kind of see how that kind of decides the flow. And you can kind of see a little bit of a backbone here. All these sensors kind of make it to this path, and then they'll eventually get back into the gateway. This is an interesting one here. You might be wondering why in the heck is it infrequently using this short path, but more frequently using this long path. I had the same thought. I was wondering what's going on, and when I was out at the site once, I took a look, and these two here were on separate rows, so the line of sight was through a bunch of trunks. Whereas this long path here, they were in the same row. You could see the other one at the other end, so it just could get to it that much easier because it didn't have as much matter in the way. So mesh network optimizes itself, always picking the best path and finds its way back. So if you've got a lot of nodes and a lot of paths, it's going to work wonderfully. You can run this in a daisy chain system. What I mean is a system where you have a gateway and just 1 or 2, 3 nodes in a straight line. That's fine to do, but just be aware that if there's an issue with one of these nodes, the farther ones can't make it back. So it's not required, but it's ideal to have a few more around, or for them to be arranged in a way that there can be multiple paths. All right, let me go back to where I was. So we were on the EnviroMonitor app, and installing it. So once you install it, once you check your signal strengths in your battery, you're good to go. You can go back, leave the field, and start monitoring the data. One last thing, when I mentioned the health data and looking at battery and signal strength information, this app will actually allow you to look at that information remotely. So you can be back at home or off-site and somewhere else, and take a look at what the battery voltages are, what the signal strengths are. As far as batteries go, we actually will email the account holder if the battery is getting low. We sent an email about 2 weeks before it could die. Lots of variables there. The sun could come back and it won't die. But we give you, if it's going to follow the same slope, we shoot that email out to you about 2 weeks before it's going to go, and let you know that there's an issue. Like I said earlier, you should not be having battery problems. If you get sun on that panel, you're going to be fine. We've got these in far north and south latitudes with low angled sun and dark winters, and they do just fine there. Once you get up to where it's actually dark for 6 months in the winter, obviously not, the battery would drain there. Most people stop the system then, because they're not they're farming or doing anything at those times anyway. But the point being, you get an email when you lose reception from any of the nodes or the batteries get low. You get kind of an update. But I wanted to point out that in this app, you can look at some of these health metrics. All right, so let's move on. Weatherlink.com. Once the data is shooting up to the cloud, you can look at it on our website, weatherlink.com. There's a couple different ways to look at data. You can look at a live dashboard. That's the tablet here. We call that the bulletin. It's configurable. You got to decide what tiles, what sensors, what variables are on there, where they're positioned, what the size of them are. And it saves that, so you can always come back. That's showing you your real-time current conditions. The other picture there of the laptop, that's a graph of historical data. So all the data that's coming in for the current conditions, we'll store it in a database. Remember, you have that transmission interval 5, 15, or 60. And you'll have a database of records every 15 minutes, let's say, that you can run reports, generate graphs, and whatnot like this. Looks like time's running a little bit, so I'm going to start talking a bit faster. I want to definitely have at least a few minutes left at the end for any last-minute questions. Here's an example of some graphs. So we've got on the top one a number of soil moisture probes at different depths. We're showing the ET by hour, and rainfall value, which I don't even think there's any rain on there. And then down below, we've got a couple of soil moistures, ET again, and we've got dew point and the temperature plotted on there. So you can do a lot of analysis by generating plots and graphs and looking at how things behave, monitoring your soil moisture, deciding when it's time to irrigate, things like that. So that's weatherlink.com, our website. We've got another app called Mobilize. And this is so you can look at information while you're mobile, while you're out in your truck, while you're out in the field, while you're somewhere else, and you can't access weatherlink.com, the weatherlink.com website. So in the Mobilize app, what you do is you create views of what you want to see, and then you come back and look at that, right? So there are, on this image here, you can see that there's views called West Orchard, North Cherries, Tomatoes, and Findel. So you can make multiple views. Inside each of those individual views, you set up these reports, right? And there's 5 different reports you can do. You'll see that on the right image there: a frost report, a weather report, a crop report, and an irrigation report. And the 5th one is IPM for pest management. I think we got some slides on those. Yeah, so here's the irrigation management. What you do when you set this view and report up is it asks you which sensors you want to use for the report. You tell it to use that particular soil moisture sensor, and you input some thresholds of what your wilt threshold, your saturation threshold. That's the colored bars in this graph. So when you set it up, there's some questions you answer and define some thresholds. Then you come back later and you look at it. So we have a text view here where you can see all the soil moisture values. You can see the soil moisture values stacked on a chart. You can see if they get in the wilt zone, and kind of do some analysis there and decide your irrigation scheduling. The frost tracking is going to use a temperature probe and a humidity sensor to get you some wet bulb values. Obviously mainly for frost, so you'll set your thresholds. There's two. You can be alerted when it's close to freezing, and then when it is at freezing, and come in here and monitor the system. You can see on the right that the frost tracking actually has a forecast. So we'll run out and grab a forecast for your latitude, longitude, and kind of give you a heads up of what to expect in the future. You know, maybe frost is coming in a couple days. You can see on the left image there that the duration is going to be about 11 hours, and it looks like it's going to come Thursday. Notice the numbers, 48.6 up there in red. In the Mobilize app, when you hit a threshold, notice here, you get, they turn colors to tell you there's an issue, like this orange here and that yellow there. And you get a little flag up here, and you can swipe to the right and find out what these 4 issues are, whether you reached your maximum wind gust or lowest soil moisture value. You can see what triggered, and then you can also go inside these and see what's triggering and why you got the alert. So here things are red, and this is the reason, right? Frost is coming, and it wanted to alert you, so you do get alerts. The crop management report, that's going to be calculated degree days, so you can assess the life cycle of the plant and track degree days through it. Similarly, it also does a forecasting, and we'll eventually adjust that forecast as we get real data from our sensors, but at least gives you a heads up of what we believe is coming in the future, so you can make decisions there. The weather report, that's using that sensor suite, the combination of sensors we talked about earlier, and is showing you the current conditions from that: temperature, humidity, wind speed, barometric pressure, things like that. There's a text option, there's a graphing option. You can see there we're looking at temperature and rain. Likewise, to the right of the dotted line is the forecast of what you can expect to come up. Then the pest management operates a little bit differently. Normally you just need a temperature probe, maybe a leaf wetness sensor, a humidity sensor, depending on what pest or disease you're modeling. We've got lots of pests, lots of diseases for many crops. We have a list online. Maybe Joel can share you a link to that shows you all the different pests and disease models that we have. But when you set this up, you pick the sensor you want to use, you pick the disease or the pest that you want to track, and then it starts monitoring that and lets you know when the risk gets high and you need to take action out there with your crops. You can see on the right image there, we've also got a little wiki that gives you information, shows you a picture of what the disease or the pest would look like, and some more technical information on the disease or the pest. Okay, so we got about 15 minutes left. We're close to the end here. If you have any final questions, so this we talked about earlier. This is the typical mesh network and how things kind of transmit back. These are some common builds for the systems. A lot of different combinations, right? First one just has the IP gateway and a sensor suite. The IPM system modeled there, it's got a node and a couple sensors for it, as well as a sensor suite with the cellular gateway. So a lot of combinations depending on how many nodes you get and what sensors and things like that. So a few combinations there. So there we go. So EnviroMonitor, it's very rugged. These things last out in the world. I mean, people ask how long it'll last. I say kind of 5 to 7, maybe 10 if you keep it shined up and clean it and things like that and maintain it. I've talked to people that have had systems 14, 15, 17 years, believe it or not. It's just kind of how well you maintain it. So it's very rugged. It's meant to be outdoors, last outdoors. All our shelters are really waterproof, no corrosions there. It's super easy to install. Most of the time you're just U-bolting or lag bolting into a pole or a post. And the installation with the app is relatively seamless with the Bluetooth. You just walk up to it, answer some questions, and it configures it, and you're done. Not as expensive as some other larger competitors out there, so we're good in that sense. The third-party sensors is really where we come in, right? We can take a lot of different sensors, and you can expand it, right? You get 1 node now, you can always add 3 nodes later, and things like that. So that's the general overview. Here's Joel's contact information if you want to be set up as a reseller or have questions, things like that. He's a good source for things like that. I've got a short poll here I want to give to you guys, and then after that, if you have any questions in the Q&A section that we can answer, we're happy to stay a little bit longer and answer them. I hope that was helpful. In the poll, it'd be nice to know what you're interested in. You know, maybe we can do this again and do a little bit deeper dive into troubleshooting or mesh networks or sensor integration. We have APIs, so you can get at the data from our server and dump the data into your own software interface and build your own interface. So lots of options. So there you go. I hope it was helpful. Answer the poll, throw any questions that you still have into the Q&A, and if not, we'll see you next time. I know you want to see my face, but I'll go ahead and leave Joel's information up there. That might be more valuable. So you're going to say something, Joel?
I appreciate everybody coming on board, and if you have any questions at all, please feel free to email myself, and we'll be happy at any time, and we'll be happy to get back to you with answers.
Great. It's been a pleasure, everybody. Thank you, and we'll do it again.